watching Floyd Steinberg's YouTube channel. It's been a few months since I first introduced my $30 chord prediction machine, based on a smart home control knob. But I have some news to share, as I finally finished the PCB, which enables USB MIDI and TRS MIDI. I've also 3D printed this lid, which fits on there snugly, so you can place this contraption on your synth or your desk. Today's video is sponsored by PCB Way, who covered the budget for one product iteration and also had plenty of advice to give while designing the PCB. PCB Way has a big 12-year anniversary celebration going on right now, with coupons and discounts and PCB color options for your next project. So after watching my 5-minute KiCad tutorial in this video, you can start right away. Links are in this video's description. So thank you very much, PCB Way. More on the process later. So if you're interested in what this thing can do now and how to use it, please join me for the next minutes in this video. Here we go. This is the first time I've designed my own PCB, and if you want to try it as well, here's a compact walkthrough of the entire process. To begin with, you'll need an open source program called KiCad. I'm using version 9 here. Create a new project, then open the schematic editor where you'll draw the electrical circuit. Press A on the keyboard to add components. In the dialog that appears, you can search through KiCad's extensive parts library. I'm adding two JST 4-pin connectors, one for USB and one for MIDI. Place them anywhere on the canvas. Next, I add a USB-C port, a 6N1238 optocoupler, two stereo TRS audio jacks that will serve as MIDI ports, and one 1N4148 diode and 3 resistors. These parts form a typical MIDI in-out circuit. Once everything is placed, select the Draw Wires tool and connect the USB receptacle as shown in the video. Rotate the diode by 90 degrees clockwise and wire it up as demonstrated. Wires may overlap visually without being connected. You'll know they're actually linked when a green dot appears at the intersection. If there's no green dot, they're not connected, which is exactly what we want. After wiring, we need to set the resistor values. Choose the mouse pointer tool, double-click each resistor and enter the correct values. Two 220 ohm resistors and one 10 kilo ohm resistor. Next, replace the 6N138 with the HCPL 0600, which is its SMD version. Double-click the symbol and simply change its value to HCPL 0600. Now assign footprints to all the components. Footprints define the physical shape and size of each part. The optocoupler uses a SOIC 8 footprint, the resistors are 0603 1608, the connectors are JSD GH, the diode is SOD 123, and the MIDI jacks are SJ3523 SMT horizontal. Save the schematic, close it, and then open the PCB editor. Go to Tools, Update PCB from Schematic to import everything. Now we draw the PCB outline. In the right column, select the edge cuts layer, then choose the Draw Circle tool. The knob is 46 mm in diameter, so I draw a circle and set its radius to 23 mm. I also add 4 holes for the reset and boot buttons and for the 2 screws that hold the part in place. Additionally, there are 4 rectangular cutouts. Make sure their dimensions are accurate. With the outline done, arrange all the components to the PCB. When you're satisfied with the layout, select the Draw Traces tool. KiCad highlights the required connections and automatically suggests good routing paths. If a trace gets blocked, press V while drawing. This creates a wire, allowing you to continue routing on the other side of the PCB. Once everything is routed, we can generate the files needed for manufacturing at PCB Way. Open File, Plot, Gerber, then click Plot. After that, export the drill files using the button in the lower right corner. Next, generate the bill of materials in the Fabrication Outputs menu. Finally, export the component placement file. Collect all of these files into a zip archive and log into PCB Way's website. Choose PCB Assembly, fill out the form as shown in the video, and upload your zip file. The minimum order quantity is 5 PCBs, so it's a good idea to team up with a few people. By the way, after uploading, one of PCB Way's engineers contacted me and pointed out a few issues with my design, giving me the chance to fix them before entering production. Manufacturing and shipping took roughly 3 weeks, and now the finished PCB is finally here. So today this parcel finally arrived from PCB Way. Let's take a look at this. Okay, so excited. 1, 2, 3, 4, 5 pieces. This is like Christmas. Okay, let's take a look here. So we've got all the labels are correct. MIDI in, MIDI out, USB, MIDI, USB-C, and all the holes and cutouts. So I hope we can attach it to this thing here. Let's try this. So first carefully remove the cable here. Now remove the 2 screws holding this in place. Okay, now we can remove the lid, and if everything went according to plan, this should now fit on here neatly. And now we can just reattach the screws. And that's it. There you go. Now we should be able to connect this to this with some cables, and yeah, I think this looks pretty nice. So let's see if I have some cables here. Boot and reset buttons are still working. Yeah, so far so good. The next step is to create some very short JST 4-pin adapter cables. I tried to crimp 1mm connectors, but it's really not fun, so in the end I resorted to cutting, soldering and shrink wrapping. And here's the result. Looks a bit like spider legs. Let's cover that up with a 3D printed lid. And here it is. It's designed to snap around the TRS and USB ports, so it won't come loose. All in all, the experience with PCB Way has been very pleasant, and thanks especially to Freya for patiently guiding me through the process and pointing out the flaws in the first iterations of my design. So if you want to start designing your own SMD PCBs, I hope this video helped you a bit. Uploading your project files to PCB Way's homepage can feel a little overwhelming at first, but the rule of thumb there is just stick with the standard settings, and if something isn't right, one of their engineers will talk to you. One thing I learned in the process is that KiCad is great software, but you can't rely on its internal parts database 100%. For example, KiCad assumed that the 6N138 optocoupler has an SMD version, when in fact it really doesn't have it. So always double check your designs and look up the online documentations to check for the correct electrical and physical dimensions of the products you're going to use in your designs. Also, I found there are major problems if you upgrade from KiCad 9 to KiCad 10 and then import a KiCad 9 project into KiCad 10. Best idea is to start a fresh project in KiCad 10 or just keep using the older version with the specific project you've started with. But now let's take a look at the cool new functions I built into this. Okay, let's start by quickly reintroducing this device. So this is a chord analysis and prediction machine. It's connected to your keyboard, and then you can start playing chords. And it will tell you which the chords are. For example, this is a C sharp suspended 4. This is an F major 7th chord, and so on. Depending on which chords you choose to play, you'll get suggestions on the screen here, and then you can start tapping those buttons to play those chords. At certain points in your chord progression, the device will start flashing red, and then you can push down the screen to get an so-called emotional chord. Which will kind of fit in the chords you played, but take the whole thing into a different direction. You can use the wheel that is built around the screen to switch to different pages of chord complexity. So these are the diatonic chords here. But we also have functional chords, related keys where you can trigger a key change. And we have the chromatic and altered chords with really out there stuff. Another cool function is you can play passing chords by pushing the button in the middle of the screen. Let me show you. So passing chords are found in gospel music and jazz and in church music in general. So they spice up simple chord progressions to sound much more emotional and interesting. And when I mentioned the word gospel in my last video on this device, this triggered a lot of people the wrong way for whatever reason. Some people asked me if I could just create the opposite function and play the most ill-fitting chord out of all possible chords in that key. And yes, you can do that now. Let's play some chords until this device starts flashing again. And now if you turn the screen to the left, you will get the worst possible continuation of that. So it kind of fits into the key you're in, but it's the most out there chord of all them all. Another feature my viewers requested was that we should be able to roll the chords. You can play like this, which is pretty straight, and now the device will play in the same style. But you can also play like this, a rolling chord. Now listen to this. And the device will react to your velocity. So if you play softly, and if you play harshly, the difference is clear. You can also add bass notes to the chords you play. For this, push the screen down once. If you push the screen once again, the bass will be played in the root note of the key you're playing in at the moment. I have added menus to the screen. Pull down the menu by swiping over the edge of the screen. You can do this from 4 directions. And we have the MIDI setup screen here where you can set up the chords to play on certain channels, the bass to play on certain channels. You can set up the velocity of the chords, and you can also set up the ring on the screen to be a CC controller. Target of the CC commands can be selected here as well. For example, we can redirect CC messages to the arpeggiator and then tell the device which CC to send on that channel. Later I will show you the arpeggiator playing a synthesizer melody. We will use the ring to control filter cutoff frequency. Swiping from the right brings us to the tempo screen, where you can set up the tempo obviously. And we can also activate a metronome, which will play a bass drum on the 4. And we can also turn on an arpeggiator and determine the style in which the arpeggiator should play. So we can play notes up, notes down, or a user style. Let's start by playing notes up. As you've probably noticed, the arpeggiator will also quantize your inputs, so your input of chord changes will fall onto the next arpeggiator node. It's also possible to set up a user arpeggiator. Let's take a look at that. First, open the menu and then select the user style, and let's choose a note length of 8. So we have 8 steps in the arpeggiator. Now, go back to the main screen and turn the dial left, and now you can define each step of the arpeggiator. Let's start with first note, and now let's skip the next step. Skip. Skip. Alright, let's listen to the result. As you've probably noticed, the arpeggiator is nudging some of the notes into the right direction, one half tone up or down, so they match the chord you're playing, because in each key there are major chords and minor chords, and some of the notes you entered into your melody might clash, so they get adjusted on the fly. One last thing I want to show you is I've added a chord suggestion in the chord sequencer. Let's play 2 chords here. Now you can go to the chord sequencer or chord history, and you will see the last 2 chords you played on the keyboard. And if you hold this down for a second, the sequencer will fill up all the slots here with chords it deems appropriate. There it is, and I programmed this in a way that 1 or 2 out there chords are used as well. Let's listen to this. I'll turn on bass first. So there you have it. I'll now wrap up this video with a multitimbral demonstration of the bass, chords, arpeggiator and drums, all played by this device here. Yep, and that's it for today. My chord prediction machine, now called Knob. And thanks again to PCB Way for sponsoring this video. If you want to buy the assembled PCB, I've put a link in this video's description. As usual, thanks for watching, and see you again next week. Bye bye.